Hello, protocols, packets, and programs. Last night was the Superflower Blood Moon, which, in other circumstances, wouldn't make for a bad passphrase. But now that everyone knows about it, I have to change mine to Superflower Blood Moon 2. But Blood Moon 2 isn't as good as FIDO 2, which uses public key cryptography that avoids the need for memory of superflowery entropy when it can just be a credential ID between that server and me. Which means this week we talk with Brian Glas about developing future cybersecurity contributors at the undergrad level and what the industry can do to help. In the news segment, typo squatting spreads to Rust, curl fixes some dots and slashes, OpenSSF has a 10-point plan, and more. Tap a security key and stay tuned for Application Security Weekly.
This is Security Weekly, for security professionals, by security professionals. It's the show to learn the latest tools, techniques, and processes necessary to understand DevOps, application security, and cloud security. Your trusted source for the latest application security news. It's time for Application Security Weekly.
SUSE.io makes security tools for everyone. SUSE's flat rate pricing means you can set up SCA and DAST tools for your whole team. No seat counts, no scan limits, and you never have to talk to a salesperson. SUSE integrates with all common CI/CD platforms and supports most popular package managers. And thanks to SUSE's open source vulnerability scanner, license management suite, and SBOM generation capability, you can get back to what you really want to be doing, coding in no time. Visit securityweekly.com/SUSE. This is episode 197, recorded May 16th, 2022. I'm your host, Mike Shima, and I'm here with John Kinsella. Hello, John.
Hey, Mike. I'm looking forward to the next half hour of talking about planes and all things related.
We got to find out what your call sign is, so let us know. And while you're thinking of that, don't miss any of your favorite Security Weekly content. Visit securityweekly.com/subscribe to subscribe to any of our podcast feeds and have all new episodes downloaded right to your phone. You can also join our mailing list, Discord server, and follow us on social media and our streaming platforms. And don't forget to check out our library of on-demand webcasts and technical trainings at securityweekly.com/on-demand. And if you are interested in planes, we'll talk John into giving us a special security and aviation training sometime. But right now we have Brian Glas, who has over 20 years of experience in various roles in IT and over a decade and a half of that in application development and security. His day job is serving as an assistant professor teaching a full load of computer science and cybersecurity classes at Union University. He helped build FedEx's AppSec team, worked on the trustworthy computing team at Microsoft, consulted on software security for years, and served as a project lead and active contributor to OWASP SAM and the top 10s of 2017 and 2021. Brian is a contributor to the Rabbit 5 pilot program for election-related technology. It might be Rabbit V. But in any case, we have Rabbit V here with us with Brian. Hello, Brian. Thank you for joining us.
Thanks, Mike.
So Rabbit V isn't actually why we brought you here. We brought you here because John and I in the past have talked about educating the next generation of cybersecurity professionals. And you actually do that. But before we get right into the education part and talking about the undergrad level at the university, tell us maybe a bit, how did you get to that point? Because you do have quite a varied background.
So that's an interesting story, how I got into it. So I had been working for almost 20 years, different organizations, consulting and such. And my wife and I were like, all right, what's next? What's our next plan? And when I graduated with a bachelor's in computer science, the dream was one day maybe I'll go back and teach. And we have 4 kids, and the oldest was, she was like a senior in high school. We were getting close. And I had kind of discarded the idea because I figured, I needed a doctorate and I needed all of that before I could go teach. And I kind of missed my window. And then my alma mater posted a job for computer science professor. And my wife noticed it and she was like, hey, you remember all that time back there where you said this is really what you wanted to do one day? Do you really want to do it? So lots of soul searching, lots of praying, lots of thinking, discussing, because higher ed does not pay like the industry does.
No.
So to balance that out, right? So you get a lot of universities, you get faculty discount if your kids go. So that helps. So I consider that the investment. But actually had the opportunity to go back. The chair of the computer science department was still the same as when I was an undergrad. So that was kind of really cool and a lot to get used to, because he used to be my advisor and now he's my boss. But I kind of decided that I wanted to quit complaining about the people, like just the lack of knowledge and understanding for people entering the industry, and like do something about it. It's like, can I help contribute to multiple generations of people coming into the industry? Can we improve things? And that's something I've always chased in terms of like, how do you have a larger impact on the industry? Like, how do you better the industry? Not just do what you're working on now, but how can you shape it toward improving something larger?
Well, definitely have to say, it's a lot easier to just complain. It's a little bit harder to do something about it. So absolutely have to start off with the congratulations for the doing something. And so part of that is then, what do you do? And what I mean in that is sort of, you were at FedEx, worked on trustworthy computing. What parts of that started to influence a syllabus, or what areas that you thought were worthwhile to educate the next generation on?
So I got to start with a blank slate. So one of the things they asked me when I came here, they're like, hey, if you come, we really want you to build a full cybersecurity program. So a full degree program. They didn't have anything yet. And so one of the things I always did when I was working is I'm primarily application security. Most of my space was working on like the software assurance maturity model, program level, large scale stuff. But I always wanted to know how it fit in the grand scheme of things, because the cybersecurity discipline's huge. It's very broad, very diverse, and there's a ton of elements in it. And so if you dig through my employment history, like I played with incident response for a while, reverse engineering malware, some network security, just a bunch of different pieces, because I wanted to know how. I'm always looking for new perspectives and how things fit together. So when I looked at trying to build the program, I researched a bunch of other programs at other universities, trying to figure out like, what's the model, how are they structured, kind of thing, and found that the majority so far were largely computer science with emphasis in cybersecurity, where you'd have 3 or 4 courses, and you'd have like a network security course and maybe a hacking course and maybe an incident response, enough so that you can get the name recognition out there, but not like a full-blown, like comprehensive foundational type. So I went through, when I built it, I went through the core, the ACM, the Association of Computing Machinery, puts out essentially a straw man for 2 and 4 year degree programs. So I went through that. I went through ABET accreditation, went through their list of things. And then I also went through the 8 domains within the CISSP. So my goal was essentially to create a broad foundational program, so that when you're done, you have the majority of the knowledge you would need to be able to do, be able to pass like the associate CISSP, and then be able to understand the overall landscape of cybersecurity, that you would be knowledgeable enough that you could start into any of the particular areas. Because most of the students I've run into so far, when they come in, they're like, I really like the idea of security. I'm not sure which part of it I want yet.
Mm-hmm.
Yeah, and there's absolutely an amazing amount of complexity or depth you can go into. Set aside AppSec for the moment, but you were talking about incident response, just pure programming concepts, secure architecture there, which I guess is some AppSec, so we didn't set that aside. But governance, even business aspects, and human and management aspects of this. So we'll maybe touch on some of those as we continue the conversation. But I do want to touch on those aspects of AppSec. And one of the questions is maybe getting into details of the sense of, what about languages? What does that look like? Are you still teaching, C and Fortran, maybe some Java? How do you approach that aspect of, the OWASP Top 10, for example?
So when I built the program, so about half the classes are computer science, and the other half are very cybersecurity specific. And so at our university, we teach, one of the intro programming classes is in Java, because it's still one of the more common object-oriented programming languages. I'll get into debates with people over whether that's the right one at times, because some people love Java and some people don't. We'll also get into Python. So when we get into any of the data analytics, AI level stuff, we get into a good bit of Python. I'll still get into programming in C because it's a procedural language, and so it's a different type of language. And so it's always the balance that we have to strike is teaching you foundational principles for things, but also applicable skills. And so, that's the challenge. And one of the challenges right now is there's so many different languages that are popular and frameworks is which ones do you teach? Because academia moves slower by nature. And so when we develop a class, when we choose a language, we're choosing it for years. Because when you develop a new class, each time you teach it, you refine it. And it's usually 2 or 3 years before your class is fully refined to where you like it. And so decisions that you make are like longer running decisions. But like for me, to really understand how to secure things, you need to know how they work. And so everyone has to take a class in like, this is how programming works. This is how databases work. This is how operating systems work. This is how cloud works, and all along those lines.
There's also an aspect of, I do agree. And I want to add on to that, in addition to this is how the code works, there's also, I think, an aspect, this is how engineering teams work. This is how organizations work, as well as this is how the end user works that consumes that. There's the classic why Johnny can't encrypt, talking about GPG. So how do these influence call them the human elements, perhaps, influence how you approach the educational aspect?
So those, I love that you bring that up. So my minor was psychology, right? So I love messing with people, or at least that's what I tell my students. I love messing with people. I like just how things work. And so one of the things that really caught me from working in the industry was we have a tendency to forget, even with all this technology, it's humans that make things work. It's humans that make the decisions. Humans decide, how to do things, what to implement, what to tell the computer to do. And so that factors in a lot of my classes when we talk about things, that we have to make sure that the humans aren't ignored. Like, this is not objects. They're not just entities. Like I get to teach HCI, so human computer interaction. So we go through a lot of the psychology behind how do you create an experience that somebody actually enjoys using your software. Not just like can functionally do it, but like enjoys, goes and tells a friend that says, hey, I enjoyed using X software. And it seems weird, but it's a really hard thing to do.
Yeah, I think trying to memorize all the command line flags to Nmap or something is not easy. That's an old school tool, and I'm not sure that the many modern tools have improved necessarily on that. So part of what I want to bring into the conversation now, an aspect of to continue to talk about, what did the syllabus look like? What you're teaching or how your approach is. But clearly you're also doing this, or at least I have my fingers crossed that we're doing this so that graduates come into the business world and they can succeed, and we can maybe get rid of like at least the SQL injection and cross-site scripting entries off of the top 10. So, what does it look like for getting the undergrads to be prepared to get into the quote unquote real world out when they actually have to start, working as interns, working as this is their first job? So
for me, like a lot of that, I can leverage or lean on a lot of years of experience in the field. So I can say, hey, this is what the book says. This is what my experience says. Just so you know, but also that like my experience is, I also recognize is a fraction of all experiences out there. It's a subset of experiences you could have. And so I'm generally pretty clear on this was the environment, this was the context, this was my experience. So that they have something, and that usually generates lots of questions and conversations into things. In terms of trying to make sure, so we do pull secure elements into like programming, like this is how you can do database interactions, and this is how you can securely do database interactions. Please don't straight up copy things off of Stack Overflow, because the vast majority of those are not secure versions of examples. But to fix those, and this is partly why I spend time playing with the OWASP Top 10, to actually fix those things is really at a language and framework level. I can teach people to do it, but humans are not mistake proof. And so, as long as the option's there, somebody's going to consciously or unconsciously end up creating that vulnerability. And so that's where one of the things I like with the top 10 is we're given a ridiculous amount of influence, more so than we probably should. But everybody talks about it. It's really daunting to create versions of it, because we understand there's tens of thousands of person hours of work that will go into the industry to try and align with whatever the top 10 says is important, which is insanely daunting to realize that you may or may not have, you may either contribute to the industry or be a detriment, depending on what you say the top 10 actually is on any given time. But it's really the frameworks and the languages that have to be built that way, to where you essentially, the path of least resistance is the secure path. And so you have to make it hard for a developer to have to go out of their way to make an insecure version of something.
So does that tie in, or how well does that tie into the coursework? For example, I agree that teaching the concepts of procedural programming with C, even though everyone's going to start screaming, it's not memory safe, just use Rust, use something else. That's still sort of the Latin, if you will, the lingua franca of programming, Java and Python, but you're now mentioning languages and frameworks. When students come to you and they say, well, what specific tech stack should I learn? I want to get my first job, and the jobs are saying minimum of 5 years of experience. How do I get into these sorts of positions?
So when asked about tech stacks, some of it depends on where you want to work. Right? If you want to work in larger, more established Fortune 100, 500s, the Javas and the .NETs are by far still the most common languages used. You can't really go wrong looking at .NET Core or a lot of the .NET frameworks. Microsoft's done an amazing job at working in the language and frameworks to try and make them secure by default. That's part of the reason why I went over to work for the privilege to work under trustworthy computing, because I wanted to see at the headwaters of where we started with secure development, what does it look like? How do they focus on things? And some of the stuff, some of the folks there, like Mike Scavetta and Josh Brown-White, are working on is utterly amazing in terms of how they're trying to secure things at the headwaters. But then I'll tell students is if you're looking for more of a startup, smaller shops, then you can look at the Scalas and the Rusts and some of the newer languages that are fairly popular and how they're growing, right? Because every time we make something new, we make it functional first and secure later. Because it's expensive, and that's just how business works. If you made something hyper secure first, you are unlikely to succeed because you won't get off the ground. You won't get the market share needed to be able to grow.
Yeah, there's absolutely that the business aspect, the business need for we build tools for people is a bit of a callback just to that topic. We don't build a security software for the sake of security. That seems kind of there's a non-product there. So part of this, then, I'm curious that how much, I asked a little bit too about, working as teams, working within businesses. Are there ways that you do education on, how do you get business requirements for programming, or how do you drop someone into that type of environment so they can gain that appreciation that it's not just about doing all of the LLVM flags for testing all the sanitizers and input validation and memorizing all the different types of cross-site scripting. Honestly, a product manager really doesn't care about that. They care about, this is my roadmap milestone. So how much of that comes into the education that you do? So,
and it's interesting because we have senior seminar projects. So essentially your capstone. So most computer science graduates or seniors that are about to graduate end up with a software development project. So the interesting thing is at this point, they've had all of these different pieces and different elements. It's like, how can they put them all together and actually have a full-on project? So one of the courses I get to teach is more like secure software development, and it's more holistic of a life cycle. So I try and walk them through and say, look, this is what it's like, right? Requirements are one of the hardest things ever. Whether you call them user stories, requirements, however you want to do them, the human ability to document what they're thinking accurately that can be easily interpreted is ridiculously difficult. And that's part of the reason I think was the downfall of waterfall, not just that it moves slowly, is because it's very difficult for humans to articulate thoughts in written word. And so some people are much better at it, but it's a relatively small percentage of people who are good at writing very clear and concise requirements. And so we would go through exercises and say, hey, if I wrote these requirements for you, could you write a program off of it? And at first they're like, oh yeah, sure. And then they'd get like 10 minutes in and they'd have their first questions. And so we go through exercises of like, and sometimes, and it's kind of variable, but we could take 2 or 3 weeks just trying to show like, this is an example of why this part is so hard. But also I like to try. So it's an interesting challenge because by default on most universities, you're trying to teach and measure grade individuals, because you're that's what you're aiming for. And so it's an interesting challenge to work in group work, to say, hey, when you get out in the real world, when you're done with school, you have to be part of a team. You have to be a functional part of a team. You have to understand how to communicate with teammates. You need to understand like how to articulate. You have to write well. You have to communicate well. You have to present ideas. But then also some of the details of like, how do you use GitHub with multiple people? Like, what does fetch mean? What is, how do you collaborate in a way that you don't like destroy each other's stuff? And so that's one of the things too I try and emphasize is I can't teach you all the tools. I can't teach you all the methodologies. I can't teach you all the technologies, but I try and pick things like, well, let's use VS Code and let's use GitHub because they're the most common things that are used out there. And you should be able to take that knowledge and extrapolate it into a similar tool. So that they get that experience. And that way, when it comes time to do their senior project, they understand, hey, I have multiple steps when it comes to creating a piece of software. I need to be able to articulate a vision. I need to be able to create requirements. I need to be able to work with a client and collect data, ask the right questions, prototype and test things out and all of that kind of stuff.
I love that emphasis that there's that communication element too, because I'll admit I have a bias myself. I have an electrical engineering degree, but also a French degree. And I imagine that there's also a lot of people that come into the cybersecurity field either with degrees that aren't related to what you've been teaching, what you've been working on, or perhaps even without a degree. So is there also, as you're just doing education, obviously for these courses, but you're doing this based on principles, based on the psychology of how to teach people, what is advice that you would provide to those who came through, call it non-standard degrees, or even just don't have degrees?
Advice like in the workforce? Like what to do?
Either to train up, how to enter into the workforce. What are just resources, ways of getting into InfoSec?
I mean, so it's interesting. One, recognize you bring unique perspectives. Leverage that. Because anytime, especially when you get into security, there are perspectives and backgrounds that people can bring that are very non-technical, and we forget that those are immensely valuable. So take how you learn, like if you have a different language, how do you communicate? How do you interpret? That you don't make assumptions. That's one of the hardest things is trying to identify what assumptions are made and calling them out. Another huge one is expectations, making sure expectations are known. Unspoken expectations are one of the worst things to deal with. But honestly, when it comes to getting in security, and it's tough because people are like, I want to get into it now. When in reality, the best way to get into it is to know how things work. And so I had a few people when I was at, I had a young gentleman when I was speaking at B-Sides Chattanooga. And so it was a few years ago, and he was like, I want to get into security. What should I do? And I was like, well, what kinds of things do you like? And he's like, well, I'd like dealing with like systems, like configuring operating systems and stuff. I was like, then go be a sysadmin. Be a sysadmin for 2 or 3 years. Understand how that works. Understand the pain of it. And then you can start going, but go in there with a security mindset and say, I want to know how this works, but I also want to always be thinking about how is this secure? Can I make it more secure? Because then you can pivot very easily off of that base knowledge and say, hey, I know the ins and outs of how to configure this and how to install it and how the security elements work within the operating system. And then you can pivot off of that and continue to grow deeper into the more secure element of it. But to me, like I've run into a few people that have gotten into security without the background and they struggle. It's not that it can't be done. It's just hard to do without the background of understanding how things work. Like if you're a pen tester and you're working with a dev team and you've never coded in your life, telling a dev team this is easy does not come across well, especially if it's not, because you've never actually coded and you don't realize what it takes to do something. But yeah, being able to empathize with whoever you're talking to or dealing with about how things work under the covers is hugely beneficial.
I want to pick your brain, Brian, for a second on, we've been really interesting conversation, really great so far. One of the things I've been thinking about as we're talking through this is I'm sort of comparing in my head sort of CS versus a lot of the other majors you have in a college. From the point of view of, I don't know, biology's come to my mind for whatever reason. Like, biology is not really changing that quickly. My human body is still relatively within, well, think about a human. There's lots of biology, I understand, but I'm not changing too much over time. Engineering, like, maybe mechie or some of those other engineering fields, there's going to be a little more, you have to keep your toes in things. But CS and security, at least the way I'm thinking of it right now, it seems like it's vastly different, right? By the time you're talking about, like, you got to pick that language you're teaching because it takes, at least multiple teachings, if not years, to change that course in the syllabus. So a question and then thoughts off of it, like, what do you do? Presuming the answer is yes. Leading questions, here we go. But sort of thinking through, presuming that the question would be, is CS require those students to care more and to really learn how to learn and how to actually stay up to date and sort of keep things going? And then sort of, if that's the case, how do you take that into your courses or when you're teaching these classes? I broke them. Yep.
I got the CS require people to, and then I got it got stuck.
Okay, no worries. We can go over it again. So it's internet, right? The first part, the leading question is, in a CS program, are students, is there a heavier a requirement, I'll say, unspoken requirement, but still a heavier requirement to have to be able to learn how to learn? In other words, yeah, you can take this state job and use Fortran for the next 50 years, but most people going into CS don't want that for our security. And presuming that's the case, and we got the head nod, thank you, is how do you bring that into your courses? Like, you have to teach C, you have to teach some of these things you're talking about, human interaction, but then how do you sort of poke that person out of the normal sort of college mode of, okay, I'm here, there's a test coming up, to actually think about how do I actually learn this stuff on the fly?
No, it's an excellent point. And that's one of the huge challenges, right? So, and I'll tell prospective students, like, hey, some of the things I teach you in your freshman year may be obsolete by the time you graduate. So you have that to look forward to. But I mean, it is a serious challenge keeping up with what's going on, right? So one of the things I try and deal with that is and this is much more of a burden on me than the students, but it's the only way I know how to do it, is a lot of my tests are done in a way that they're not rote memorization. So most of my tests are open book, open note, and they first cheer and then they realize what this actually means. And so it basically means, and I'm generally pretty decent at it. Every now and then I'll catch a class and we'll have to redo it because I made it way too hard. But I try to write tests in a way that you need to know about half of the things off the top of your head, because you have to have at least a certain knowledge base to be able to look things up. Because if you don't know the terminology, you don't know the structure, you don't know the principles of something, it's very hard to research and grow that knowledge base. So the other half are things that you're going to have to look up. They're things that are going to be too difficult for you to try and memorize. So if you look up through your notes, you look up through the book, I'll even let you Google search. I don't care. I wrote the question. There's no secret answer on some website to this question right now. So that, because I want them to have to deal with that. Like, your job when you're done is not simply, hey, can I pull things out of short-term memory to answer questions and then I'm good. It is, I need enough knowledge to be able to start somewhere, and then I need to understand how to grow that. Because, and I'll tell them, and you're absolutely right, John, you can't stop learning. This field, you don't. Not to any level of success in your job. There are some jobs that, yeah, you can do the same thing for 20 or 30 years. But that most people aren't that way. Humans are built to be creative. We're built to try and figure things out, to do something new. Not too many people can deal with more assembly line, lather, rinse, repeat every day. That's why we build machines to do stuff like that. And so I also try to emphasize trying to understand what humans are good at and what machines are good at, and let the machines work on the stuff machines are good at, and have the humans focus on the things that humans are good at. And it's a lot of times it comes into context and creativity. The humans are good at that stuff. Machines really struggle with context and creativity. They will run themselves into the ground until they run out of power or something wears out or short circuits, but they will faithfully do the same thing you ask them to do continuously. Humans can't do the exact same thing over and over and over and over. You will burn out and you will start making large mistakes. That's why we have checklists on, like, airline pilots, right? Because they could do the same thing for 15 years, but you're going to start missing stuff.
Yeah.
Sorry, I had to tie the airline stuff back in.
Thank you.
Yes, yeah. Just so listeners know, we had probably a good 10 minutes before this geeking out on planes. So we'll try to see how many more we can squeeze in here. But unfortunately, I know we're getting close to the end of the time for this segment. But speaking of asking people to do things and making requests of people, Brian, what could industry do to help with this? I'm going to guess one easy answer is funding, just across the board. Money helps. How important is that, and what else can they do? What are the resources that industry can do to help either you directly or just these types of courses in general?
Well, funding, yeah, absolutely. Funding's part of it. It's always an interesting challenge to get funding. Look for grants, look for contributions. But I mean, even more so than funding, it's collaboration. So it's being willing from a organizational perspective to invest the time and effort to better the overall talent pool, right, for future generations. So you've hit on one of the big HR issues right now, right? So I'm doing everything I can to get current graduates or recent graduates a job. It is really hard. We have an immense number of open positions in cybersecurity, and almost every one of them says entry level has 5 years of minimum experience, which just doesn't work well. No. And so the problem is everyone is at the point where they're like, hey, I must do more with less. I can only accept experienced people. I am not willing to invest any amount of time or money to train anybody in improving. If you want to help overall, I mean, with university programs or in general, be willing to contribute to improving the overall knowledge base of cybersecurity professionals. Be willing to say, hey, one of my new hires, two of my new hires, I'm willing to train somebody. I'm willing to work with, undergraduate or graduate programs so that we can build relationships. We'll contribute some resources, we'll contribute time. And maybe we work on projects for you. help you all solve things. Or maybe you give projects and say, hey, these are types of scenarios or different kinds of projects that we run into in our industry. Do you have interest in it? Because, I mean, these kinds of things we've seen over time where like Apple and Microsoft get involved with education, and students are far more likely to work at the company or use the technology. That's how iPhones and Macs and such got into industry, right? We got all the college grads loaded up with them, and then they went job hunting and they said, I want to come here, but I want to use these tools. And so Apple broke into much more industry because of the educational route. So if you want to help those next generations, be willing to put a little resource behind it. And it's not just money. A lot of times it's time and the willingness to say, hey, I understand that if I pick a new hire, in a couple of years, they may go somewhere else and find another job. I get it. However, you might be able to pick somebody up from someone else who did that, and you now get an experienced person. And it's having that broader mindset of not just, I don't want to expense this because they may leave, but if we all do this, then everybody ends up benefiting from a whole much better, more improved talent pool to pick from, and the industry overall improves.
That's a great message, I think, for us to end on. And as I stutter through that, demonstrating good communication skills, right? But less facetiously, I think, I want to say thank you, Brian, but also just you've been working on a lot of projects. You've been working on a lot of things outside of, or I should say, in addition to education. Any parting thoughts or anything that you want to call attention to for additional participation or something that we should keep our eyes out for over the 2022?
Oh, I mean, 2022 and beyond. I mean, one of the main things I'm working on right now outside of, because the top 10 goes in cycles. So we have, maintenance things and such to do. But OAuth SAM, one of the things I'm desperately carving out time for is the SAM benchmark. So the software assurance maturity model, one of the things that people have been asking for a while is a benchmark. Like once you measure yourself for maturity, what's your very first inevitable question you're going to have? How do I compare? And you want to make sure you compare yourself against somebody that's in a similar position, right? So if you compare yourself against a Fortune 50 company who has the resources and a 30-person AppSec team, you're going to be really short. And that's one of the struggles people have had trying to compare themselves against like a BSIM report, because you're looking at a much larger or a high-end substrata of the companies that do application security. And so one of the things SAM tries to work on is being more for a much broader range, right? So smaller companies, you've got 10 developers, 30 developers, maybe 50, 100 developers, right? Can we help you figure out how to do security? Especially in the software development lifecycle, because there's very little comprehensive help out there to do it at a program level. There's little things that say, this is how you secure code. This is how you secure third-party dependency management or software supply chain, or this is how you code review or pen test. And they're all little fractional pieces. SAM is one of the very few programs, and while it's a flagship in OWASP, it's still, I think, one of the most understood and utilized programs and projects that can absolutely benefit, like how to build a program, how to maintain it, how to measure improvement in it. Like, it's huge from my perspective.
It's a great topic. I think we're going to have you back just to talk about SAM, so we can talk about how to educate the next generation and then how to build the program of what they're working on. So thank you very much for that, Brian. Appreciate it.
Sounds good. Thank you all for the time and the platform. This is amazing.
I want to thank John as well, and thank all of our listeners. We're going to take a quick break and return with news of the week.